Hi, this is Mrs. Greathouse. Let's review conversions between grams and moles and representative particles. We'll start with grams to moles. Okay, we'll try this two different ways. First, we'll do it algebraically, then we'll do it through dimensional analysis. Okay, this is our problem to start with. We are given 508 grams of ethanol, C2H6O, and we need to find the number of moles. That's our unknown. Okay, to do this algebraically, we will use the formula moles equals grams over molar mass. Okay, we are given our grams, so the grams will plug right into the numerator. Okay, we need to determine our molar mass of ethanol. Okay, we'll do that by looking at the molar mass of each element, taking into account how many we have, which is shown in our subscripts. Okay, then multiplying and adding them all up. So our molar mass of carbon is 12, and we have 2 of them, so we need to multiply by 2. Then we will add the molar mass of 6 hydrogen, which have a molar mass of 1, plus the molar mass of oxygen, which is 16. Okay, so we'll multiply first 24 plus 6 plus 16 equals 46. So our molar mass of ethanol is 46 grams per mole. Okay, so we will plug our 46 into the denominator for molar mass. So our algebra will become 508 divided by 46. Okay, if we punch this through on our calculator, we will get 11.0 moles of ethanol. Okay, that's one way to find moles. Let's find moles by dimensional analysis with the same problem. Okay, we have 508 grams of methanol, and we need to get to moles. Okay, what conversion factor will I use to get rid of grams and introduce moles? That sounds like molar mass to me. And again, our molar mass of ethanol is 46. In dimensional analysis, I can cancel out similar units that are on the top and on the bottom, so I can cross off grams. Now I need to multiply across the top and use the units that are left, so that will give me 508 moles divided by 46. On the bottom, 1 times 46 is 46. I crunched that through on my calculator, and again, my answer is 11.0 moles of ethanol. So two different ways to find the same answer, either by algebra with a formula or by canceling out similar units with dimensional analysis. Okay, let's try to do a problem and find, this time, representative particles by two methods. All right, let's say we are given 3 moles of tin. And we need to calculate representative particles. Remember, representative particles can be molecules or atoms. So read your problem carefully. In this particular problem, we will look for atoms. The formula that we will use algebraically is moles equals representative particles divided by 6.02 times 10 to the 23rd, which is Avogadro's number, or the number of particles in 1 mole. Okay, we have 3 moles of tin. That can be plugged right into the mole portion of our formula. Representative particles remains our variable, divided by 6.02 times 10 to the 23rd. Okay, to solve this algebraically, we will multiply 6.02 times 10 to the 23rd times 3, which gives us 1.81 times 10 to the 24th representative particles, which will be atoms of tin. Okay, now let's try that with dimensional analysis. All right, same problem, different method. We start out with 3 moles of tin. We need to get to our number of atoms of tin. Okay, if we need a conversion factor that is going to cancel out moles and introduce atoms. Okay, the conversion factor that will do this for us is 1 mole is equal to 6.02 times 10 to the 23rd atoms. Okay, that's how many atoms are in 1 mole. I can cancel off moles. I multiply across the top. 3 times 6.02 times 10 to the 23rd gives us 1.81 times 10 to the 24th atoms. I multiply across the bottom. It will just be over 1. So my answer again is 1.81 times 10 to the 24th atoms of tin. Okay, I hope this little refresher helped. If not, come and see me at activity period or send me an IM during homework hour. Thank you.